Today, let's talk about axis, and specifically our QRS, or our R-wave axis. Axis is just a sum of all of our vectors. So we're taking all of these individual vectors. Remember that every single little cardiac cell has its own vector, its own direction in which it is pointing the electricity over to the next cell. So this is just a sum of all the vectors. It is the overall direction in which the electricity is conducting through your heart. So we're looking at this big broad view, this sum of all of our vectors, and here we're going to be calculating and paying attention to the R wave axis, or sometimes referred to as the QRS axis. Every single little wave has its own axis. There's a P wave axis. There's a T wave axis. If you can find a U wave, there's a U wave axis. There's a Q wave axis, but we're going to be focusing on this R wave. That's the big one. It's the ventricular axis, and that's what we're going to be looking at. Should be down and to the left. It starts up in the SA node, ends down in the ventricles, should be down and to the left, and that's what we're going to be focusing on. So this axis, for right now, we'll talk about it in a two-dimensional way. So we're going to be taking our limb leads, lead 1, 2, and 3, and then our augmented limb leads, AVR, AVL, and AVF, looking at those and saying, well, in what general direction, and that's what axis does, in what general direction is our electricity flowing. Here's our two-dimensional diagram, and with each lead, all of our limb leads, all 6 of our limb leads, we have different windows. So we're looking at these windows and looking at this electricity, and we see, in lead 2, let's say, or lead 1, electricity should be flowing down and to the left here. So it should be positive in lead 1, lead 2. AVF, again, should be primarily positive. If we looked at AVR in a normal heart, electricity is flowing away from this window. It's getting smaller and smaller and smaller, smaller. So in AVR should be negative. So your QRS complex, and that's what we're looking at here, this QRS, this R wave axis, should be positive in some leads and should be negative in others, like AVR. But here's our two-dimensional view, and this is going to be our starting point. And I have a few steps to calculate our own axis. First thing we're going to do is find a quadrant, and we'll define that here in a few seconds. But we're going to define our quadrant, find our quadrant in which the electricity is flowing. Then we're going to find our isoelectric lead. We're going to find the closest lead, and that closest in quotation marks, closest to that isoelectric lead. And again, we'll define that, and we'll explain that. Then we're going to narrow it in a little bit, and then we're going to double check our findings. So we're starting big and broad with the quadrant, getting down to step 4, we're really narrowing down to get an actual number, an actual degree number for our axis, and then finally we're gonna double check those findings. Now the very first thing we're gonna do is find our quadrant, and yes, there are 4 quadrants. We've got your normal quadrant, and if we look at this, kind of down into the left. Look at that, right down here is your normal axis area. We've got left axis deviation, LAD, left axis deviation up here. There's a little bit of like overlap here. We're gonna get to that later. But we've got left axis deviation up here. We've got right axis deviation right down here. So if the electricity is flowing in this general direction, remember these are just general directions. We've got right axis deviations going to the right side of the heart more than the left side of the heart, and we've got extreme right axis deviation or extreme axis deviation. So instead of the electricity flowing up and down to the left in this normal axis quadrant, somehow, some way, it's flowing that way. It's flowing in the opposite direction, and we'll talk about typical or common findings with all these extreme right axis deviation, right axis deviation, left axis deviation. But hopefully, you, me, and your patient are in that normal axis quadrant. Well, how in the world do we figure out which quadrant that we're in, or which quadrant the electricity is flowing into? Well, we're gonna we're going to look at two leads. We're going to take our limb leads. We're going to look at lead 1. We're going to look at lead AVF. That's it. Lead 1 and AVF. That's all you need to look at right now. Two leads, lead 1, lead AVF. Repeat it with me. Lead 1 and AVF. That's it. Don't overthink it. Lead 1 and AVF. So if we were to take this hexaxial diagram and look through lead 1, look in this direction, this kind of eastern hemisphere here should be positive. This western hemisphere would be negative, right? If things are flowing into this eastern hemisphere, here's my window right here at lead 1. Things are going to be coming towards me, or generally towards me. So they're going to be positive. They're going into this western hemisphere. They're going away from me, or generally away from my window. They're going to be negative, right? Same thing with AVF. AVF is down here on our hexaxial diagram. So if things are flowing into the southern hemisphere here, they're generally coming towards me, and they're going to be generally positive. If they're going to the northern hemisphere, they're generally going away from me. They're going to be generally negative. So we put these two together, lead 1 and AVF, and we get our 4 quadrants. So in our normal quadrant here, AVF will be positive, lead 1 will be positive, and when I say positive and when I say negative, I mean mostly positive or mostly negative. There might be some biphasic portion to it. There might be some negativity in here, right? In lead 1 might have like a little bit negative, but is it more positive or more negative? Which way is it mostly? Is it mostly up or mostly down? And then we slap this kind of binary dichotomous tag to it, positive or negative. So positive lead 1, positive AVF, that's our normal quadrant right down here. That's where it should be. It's where electricity should be flowing. It's down in this direction. Our left axis deviation is going to be right up here. And lead 1 is going to be positive, but AVF is going to be negative. So they should both be positive. So if we see a difference in that, or a deviation from that, then we've got some axis deviation. In left axis deviation, we got positive in lead 1 and negative in AVF. This quadrant down here is our right axis deviation quadrant, and here it's just flipped. Instead of left being positive in 1, negative in AVF, we get negative in lead 1 and positive in AVF. And again, this is mostly negative. Doesn't have to be completely negative, just mostly negative. This doesn't have to be completely positive. It can be just a little bit more positive than it is negative. So we're just making this kind of binary determination. So negative in lead 1, positive in AVF. Up here in our extreme right axis deviation, or extreme axis deviation, we've got negative in both. So normal is positive in AVF and positive in 1. Extreme is negative in 1 and negative in AVF. So again, our normal quadrant, positive in 1, positive in AVF. Our left axis deviation quadrant, positive in 1, but negative in AVF. Our right axis deviation quadrant, negative in 1, positive in AVF. And then our extreme right axis quadrant is negative 1 and negative AVF. For those of you who like tables instead of charts, graphs, pictures, here's one for you. We've got lead 1, lead 2, and then lead 3 in AVF. We're going to take out lead 2 for the moment at least. So we're focusing on lead 1, and then for our purposes we're focusing on AVF here. So you can look at lead 3 as well, but we are looking at AVF. So we're looking at lead 1 and AVF. If we are positive in 1 in AVF, we're normal. If we are positive in 1 but negative in AVF, we've got left axis deviation. We'll get into this physiological and pathological in a little bit, but we've got left axis deviation here, and that's when we're going to throw in lead 2. But for right now, positive 1, negative AVF, we've got left axis deviation. If we are negative in 1, positive in AVF, we have right axis deviation. If we are negative in both lead 1 and AVF, we've got extreme right axis deviation, and the numbers to correspond there with you as we go around that hexaxial diagram. If we are just like totally isoelectric, totally just equiphasic, um, equally positive to equally negative, then they're like, well, I don't know. But this is rarely the case. So, are we even just a little bit more positive or even just a little bit more negative? We'll tag on that positive or negative determination. So let's practice real quick. We've got a number of examples to go through. So let's start with, well, number one. We've got lead one, we've got AVF here, and lead one. What do you see? Is it positive? Is it negative? Is it a little bit more positive? Is it a little bit more negative? What about AVF? Same thing. Is it positive or is it negative? I think we can agree that this is positive. So AVF is completely positive, but lead one's got some positivity, it's got some negativity. So we've got to stamp something onto that. Is it a little bit more positive, a little bit more negative? So we're going to call that just a little bit more positive. And if you took out your handy dandy calipers that I know you all went out and purchased, you all went to Amazon, you all got a pair of calipers, and they showed up just in time for this lecture. Imagine that. That's awesome. So lead one is just a little bit more positive, so we're going to call that positive. AVF, obviously positive, so positive, positive, and we have a normal axis right there. In 2, or example 2, we've got positive, same complex, right, in lead 1, so a little bit more positive. AVF, it's got some positivity to it, but it's a lot more negative here. A lot more negative. So AVF we're going to call negative. We're going to call that down. So up and down. And that's left axis deviation. Example 3. AVF, I think we can agree that that is mostly positive. There's a little bit of negativity. There's a little Q wave right there. But it's almost all positive. That's a good thing. So AVF is upright. I think we can agree on that. But what about lead 1? What do you see there? There's some positivity, there's some negativity. But is it more positive? Is it more negative? So again, if we take out our handy dandy calipers and compare, it's going to be a little bit more negative. So I've got a negative lead 1, I've got a positive AVF, and that's going to be right axis deviation. And again, just looking at these two leads, and all we're doing is finding the quadrant. We're going to hone it in a little bit later, but right now just the quadrant. Just looking at these two leads, lead 1 and AVF. Example 4, same complex as, or the same lead 1 complex as example 3, so a little bit more negative. And then we look at AVF, and there's some positivity and there's some negativity to that. So is it a little bit more positive? Is it a little bit more negative? And if you haven't ordered those calipers yet, you should. You should pause this, open up a new tab. It's Amazon.com. Pretty easy. Amazon.com. Search EKG calipers. I did it yesterday. They're like $8.72. Do it. Hit buy now, and they'll be here. So AVF, a little bit more negative than it is positive. So I've got negative. At AVF, I've got negative. So negative and negative, that's extreme right axis deviation. So we're in our extreme quadrant. Example number 5. Lead 1, I think we can agree that that is positive. There's a little bit of negativity there. It's a little tiny, teeny tiny S wave, but mostly positive. We're going to call that positive. AVF, it's got some positivity and negativity to it. Since you paused this lecture and ordered those calipers and then waited 2 days for the calipers to come in. And then started this lecture back up. Oh, you can measure that this is a little bit more positive than it is negative. So positive and positive, it's a normal axis. Example number 6. Lead 1. I don't know. It's got some positivity, it's got some negativity. Right? is that? I don't know. AVF, I think we can agree that that is mostly negative. It's got a little positivity, a little tiny R wave, but that is mostly negative. This one, it's a little bit more negative than it is positive, just like a little bit. Just a teeny tiny insy binsy bit. And that's why we need calipers. That's why you should have calipers on you. Um, so negative and negative is extreme right axis deviation. So let's put all this into practice. All we're doing is picking a quadrant, and we're looking at lead 1, we're looking at AVF. And that's it. That's all we do. Lead 1 and AVF. So here, I've got this first part of the 12 lead, first half of the 12 lead, with the limb leads isolated, and lead 1 definitely upright. I think we can agree on that. AVF is, biphasic. It's got some positivity, got some negativity to it, but based on its baseline right here, if we just follow baseline, it's a little bit more positive than it is negative. So we've got positive and positive. We got positive 1, positive AVF, so we are in the normal axis quadrant. Example number 2, again we're looking at lead 1 and AVF to determine just our quadrant, our broad quadrant. Lead 1, mostly negative. Again, there is some positivity to it. There's a very tiny R wave here, but we're mostly negative, so we're going to call it negative. Right? We're just stamping this kind of binary determination onto it, binary tag onto it. So we're mostly negative in lead 1. Look at AVF, and again, there's some positivity. There's a little bit of negativity, a small S wave, but this is mostly upright. So we have an negative lead 1 and a positive AVF. So we are in the right axis deviation quadrant. And then our third example, again looking at lead 1 and AVF. That's all we have to do right now. Lead 1, all upright, so that is positive. AVF is all negative, or almost all negative. It's like a very tiny little positive wave right there, but almost all negative. So lead 1 is upright. AVF is negative. That puts us in our left axis deviation quadrant.